So our next speaker is a front-end developer with a passion for front-end product engineering. Outside of coding, his interests span early 90s movies, mid-90s music, late 90s skateboarding, and the web of the 2010s. So today, he'll be sharing his talk, Declarative by Default. So please welcome Blake Johnson.
All right, can you hear me? I can hear myself. Cool, hey everyone, I'm Blake, and I'm excited to be here. I'm a senior front-end engineer at Family Search, and I work on the best team there. And let's see, oops, delay. And recently, my career turned 15 years old. And so I just want to say I'm super grateful for the mentors I've had and the lifelong friendships I've made in my career, and this community is really rad, and I'm glad to be here. Okay, so I have found that after working in dozens of code bases that there's this clear pattern to me, at least, of the most enjoyable and successful code bases tend to lean declarative. So they're maintainable and they make solving problems fun and doing the right things easier. And so in this talk, we're going to talk about managing complexity and optimizing for change in our software, and how making declarative patterns the default can help us stay in that place of enjoyment and success. So a lot of times when if you Google, what is declarative and React is declarative, what does that mean, or whatever. So again, I'm standing on the shoulders of giants. I've never written completely declarative or functional code. But over the years, I've learned some principles that I would say have super helped out my team and the projects we've been on. So a lot of times you get a hand-wavy explanation, and so you can tell it's declarative because of the way it is. But the simplest definitions, and probably the most popular ones, just to sum it up, is that declarative focuses on what to do, while imperative focuses on how to do it. So we've got what versus how. Okay. So to illustrate this, I'm going to tell a story. I have this camera. This isn't mine, but I have one just like this sitting in my kitchen, and it's really fun to use. It's completely manual, and batteries are not included. Okay. And so I have to take the time to set it to take a photo. And so after I learned some principles, I was able to take this picture of my friend doing a nollie kickflip down some stairs at a church in Alpine, Utah. And I was excited about this photo because this camera makes it a challenge to shoot action, but I like how this one turned out because the action's frozen. You can see his skateboard's frozen upside down in midair, right? And so this photo represents an imperative situation. So with this camera, I have to focus on how to shoot the photo. So it's imperative. I have to figure out the settings to use and tell the camera. And so this is my current camera, not actually it. Thanks, Google Images, of course, and it's actually not mine. My dad has this camera, and he never uses it, so I've been using it for the last number of years. And it has all the stuff that other guy does, not exactly, but it's basically a computer, and it comes with all these automatic modes, right? And so it makes shooting action like skateboarding, which I love to do, a lot easier and simpler because I don't have to focus on how, I can focus more on what. I can select where I'm going to focus is a loaded term here. I can focus on the subject, and then I can adapt to any situation as Taylor is adapting to his misjudgment. So here, this was at the Linden Boat Harbor years ago, by the way. There's just this full pipe there. So awesome. Okay, so Devin figured it out here, but I was able to pick the best setting for the job, and I could focus more on what I was shooting than how that I was shooting it, right? And then it's all relative, like it's a spectrum, right? So this means that this camera is imperative and declarative, like our friend JavaScript, right? So I can do things that are like semi-automatic. I can say, I want this setting, you take care of the other one, considering the light and the situation and whatever, right? So let's go back to code here. So React was marketed as declarative when it was first introduced. And this fellow named Tom Ochino, I think, I don't know him, but I saw him when I went back and looked at one of the talks when React was introduced. And he said, it allows you to build user interfaces in a way that is a lot more predictable, a lot more declarative. Okay, so if we go back to the photography, I can more predictably get the photo that I want because of the awesome auto settings in the camera. And if I want to, I can set all or part of the settings, right? But is it really a battle between declarative versus imperative, right? I found this awesome YouTuber. I've put his link at the end of my talk because he kind of summed up a lot of my thoughts. But he had this thought of like, is it really a battle? And we've seen that in our example, sometimes we want precise control and sometimes we want the camera to do it for us. And so if we jump back over to code, we can see that in imperative code, we have more precise control. We want to take this array of numbers and double each one. And so we set up some state. Remember, all variables are state, not just use state. But we have to set up a for loop and then figure out how to manage the state and then mutate that array, and then it's less readable. So you might say, again, I already mentioned it's all relative, like what less readable than what, and that's kind of my point, is that it's a spectrum, right? So we can always be more declarative or less imperative, I guess, unless we go to, my great uncle that's a computer scientist that actually wrote imperative code, close to the metal. But in this declarative example, we can do the same thing. We get the same outcome of doubling each number in this array, but it's stateless, it's immutable, and it's more readable. So we can continue to go up and these levels of abstraction. So instead of imperative versus declarative battling, I like to visualize it as flipping vertical. And so I can then go higher and be more declarative, make a higher abstraction for this, wrap this expression in a function, and then I can just use it anywhere. And this is super powerful. So again, you'll notice that it's not binary and it's not a versus situation, it's more like a level situation. So one is not always better than the other, and sometimes I want to control how to deal with the array of data, and sometimes I don't. I want JavaScript to take care of it for me. And I would argue that most of the time, or many times in at least the UI code I write, I want to hand that responsibility over to the computer. And so we ask like, okay, why does all this matter? Like declarative, imperative, okay, cool. We know there's multi-paradigm languages and this has been around forever. And I've heard wise people say throughout my career, some of them are in this room, that say declarative code is easier to reason about. And I've heard this for years. And so I think that now I can appreciate this more. And having seen many apps and tried to solve many problems and seen how the front end space and just everything has changed so much, I can see that declarative patterns help us better manage the complexity of building UIs. And so things like managing state over time are very difficult for us to hold in our heads. So we're gonna go back in time to plain DOM. And let's say we have a to-do app and we would like to wire up an event handler so when we click the button, it adds our to-do, right? So there's kind of 3 steps here. I didn't draw up the UI, so you just have to imagine. You've got your list, and then you've got a count, and then there's this other spot because somebody wanted this feature where the last completed to-do needs to be shown as well. So in order to add this to-do, we need to get its value from the DOM. We have to go get that element, get the text, create an element, put it in the text, or in the element, and then append that to the DOM. And then also, at the same time, we have to go update the count and the title and the other spot, as I mentioned. So now if we go back to when React was introduced, Pete Hunt introduced React, and he was paraphrasing what Dijkstra observed about our brains. He said, take this series of imperative mutations, these things that are changing over time, and try to make it look like a program that executes at a single point. And so if we go back here, you can see the difference, this versus this. So presently we have this ability, and there's many ways of managing state. But this is a declarative React version of state changing over time that is easier to reason about. And so now if we go back in time again, let's go back to photos and skateboarding. So I worked at a camera shop. I was a young photographer and skateboarder, and I had this awesome manager named Cordell, and he taught me so much about photography. And I would ask him questions all the time, and he'd always be like, well, it depends, And then that's what we like to say in programming as well as photography. It's like, it depends, like what's the best thing? And so I think it's really about the right level of abstraction. And I was frustrated, but I was having fun, and I wanted to learn principles that I could use to take a great photo in any situation. Right? So the best camera isn't auto or manual. The best camera allows you to focus on and control what matters in your photo. And it's also been said that the best camera is the one that you have with you, right? When you see the UFO. So then what about the best code? The best code isn't necessarily declarative or imperative. The best code allows you to work at the right level of abstraction for your context. You can drop down to a lower level or create a higher level of abstraction when needed. So in this situation, this is at the Orem skate park a number of years ago. This is Chris, and he is ollieing over this hip. And so if I just turned the camera to the declarative auto mode, hey, I'm shooting action, it's gonna freeze the action like the one on the left, but maybe I don't wanna do that. I wanna be creative. I'm trying to hold my camera really still, and when he ollies, I hit the button, and I've got like a shutter speed that's like 1/60th of a second. Sorry to get into jargon, but it shows action by blurring it instead of freezing it. And so I was able to opt out of the automatic mode, and then manually adjusted a setting. Okay, so Dan captured this idea really well. Dan, first name basis, I'm just afraid to say his last name. Dan captures this idea really well in an article called Optimize for Change that I drew a lot from in this talk. He says that good APIs are designed to anticipate how code will evolve over time. And he goes on to say that great APIs anticipate that you'll want to move some code, copy and paste some part, rename it, unify special cases into generic reusable helper, unwind an abstraction back into specific cases, add a hack, optimize a bottleneck, and so on. And so I think that really characterizes the kind of golden parts of my career, like my career highlights is I was working in a project and there was a lot of other factors, but I was able to do this because there was the right levels of abstraction and the architecture was set up that way so that we could have fun working on this code and ship product. And so optimizing for change helps developers not only fall into the pit of success, but stay there. If you haven't heard about the pit of success, you could Google that. But it's basically, without any effort, things work out. Okay, so consider these questions next time you're building a component. Who are the consumers of this code? How will it evolve? What's the best level of abstraction here? And we've seen, I think many of us, that the most elegant code can be really hard to change, or it can break in different situations that we didn't anticipate. And so Dijkstra, who's already been quoted at this conference, says programming, when it's stripped of all of its circumstantial irrelevancies, boils down to no more and no less than very effective thinking so as to avoid unmastered complexity and separation concerns, but that's a kind of an adjacent topic. So building software in real life has a lot of inherent complexity, as we know, as JavaScript developers mainly here. There's a lot going on, a lot to manage, and it's hard for our brains to manage all that. And so the right abstractions are crucial. So we need to remember we're human beings. And I was at FluentConf about 10 years ago, and I heard Kathy Sierra speak. She gave the keynote, and I was there, and it had a huge impact on me. Excuse me. And she talked about how, by the way, she's an awesome person. You should go look up her work. But the three types of developers she talked about were there's this humanoid, there's a human, and there's a unicorn. And so if we look at this a little more closely, from this cognitive resources point of view that she took, humanoids have constantly available cognitive resources. Although I would argue using an agent to code, sometimes it doesn't feel like it's consistently available. But humans have extremely scarce and easily depleted cognitive resources, and then, of course, unicorns don't even exist. So we won't talk about those, but she warned, you've been mistaken for a humanoid. And she admitted that like a lot of her books, she's written a ton of books, she's like, potentially I've treated you as a humanoid, or our job, or whoever, and we're actually humans with finite cognitive resources. And so she gave a little refresher and made this excellent point that it's all one tank, so we should try to reduce cognitive leaks. So the one tank, she cited a bunch of studies of like a dog sitting in its kennel for 15 minutes, and then they're like in front of a treat, and then when the timer's up, open the door and he goes and gets the treat. And then he goes and does some other tests, and he's great at it because he hasn't depleted his cognitive resources. But then the other dog had to sit there, not in the kennel, and just stare at the treats for 15 minutes and then go to his test. And he did poorly because he was using his willpower to not eat the treat. And so we do this all the time, all day, right? Relevant one is reading code to understand the data flow in an unfamiliar app or part of your app, and you're using cognitive resources. Okay, so I have had a few chats with Claude just on the little website. I like him. So I asked him, tell me about this push towards declarative, and I was trying to like have it in a new context and just be totally like unbiased and just see what it would say. And this is what it said. And it talked about the push towards declarative programming in large React applications with big teams represents a shift from how to do something to what you want to achieve. And this trend is particularly pronounced because it addresses several critical challenges. So the challenges that it listed are team coordination and cognitive load, testing and reliability, predictability, and debugging, to name a few. Okay, so you may have heard that like declarative code is more testable or that kind of thing. But I want to focus on how declarative code is about reducing the cognitive load that we have on us, on ourselves as we work together. So also Claude in some other place, I should have screenshotted it, but it said, the most successful applications I've observed tend to establish clear architectural boundaries, declarative at the component and state management level, but allowing controlled imperative code in specific contexts. So you may have heard some of these things that we'll mention, like, what is it called? A functional core imperative shell, and like managing side effects and all that. But I think that over the last few years, hasn't been so much hype about declarative, but the industry continues to go that way. And there's been awesome things like declarative data fetching with React Router or React Query, and declarative routes with React Router and Zod and Framer Emotion, just to name some popular ones. Okay, so React has taught us that functions are the right abstraction for UI components, and components are functions of state, not imperative instructions, making them easier to reason about. Okay, so then if we back up again, there's all these declarative principles. I mean, just pure functions, we could talk about determinism and one I was learning about recently of referential transparency and stuff like that, but those are topics for later. I just wanted to highlight that if you're following declarative principles, you're generally working at a higher level of abstraction so that you're more concerned with the domain than its underlying parts. You're writing pure functions, you have immutable data, and you're favoring composition. I think I had one more thing to say here. Okay, never mind. Okay, so imperative code is necessary in real applications, right? It's not a bad thing. It's not like trying to be, I've figured it out, I'm a declarative or I'm a functional programmer now or whatever. And just like in my examples with taking photos, sometimes I want all the control when I'm sitting there and I have a tripod and there's a sunset, you know. But when somebody is doing a skateboarding trick down a handrail and we could get kicked out and the light isn't just right, it really helps to have the, declarative auto modes. And so I think there's room for both, right? But it comes back to that managing complexity. So, and learning and continuing to discover like what the right level of abstraction is. So building software in real life has us spending our time at various levels of abstraction, and real useful apps have state and they have side effects. There's this concept of the functional core imperative shell, similar to like dumb components and smart components or page components and UI components or whatever, where you've separated those things and pushed side effects to the edges of your app. And then we get into, there's too much. We could rabbit hole on any one of these things that I mentioned before. So the pragmatic message that I want to send is that in defaulting to using declarative patterns in our projects, it's going to help us go farther, faster, stay in that pit of success. But we don't necessarily need to force it everywhere. Sometimes it's just required and better to do one or the other. And remember that the real goal is that at least when we're working on a large team, large application, tons of users, the goal is maintainable, flexible, readable code, and that you're going to deal with over time. So let's look at another code example about the levels of abstraction. So we've got the amazing image tag. So HTML is declarative, of course. I can just stick an image on the page pointed at this photo, and it shows up. I didn't have to create the image in JavaScript like I learned how to in my first JavaScript class. I can just do that. That's for other occasions. So we can see this component, the native component of an image is simple and declarative, and it even has lazy loading now, in case you didn't know. I didn't know that was so widely supported till recently. And you could even do custom abstractions for more control, right? We could be even more declarative. And so we could put that data source on there and then use the intersection observer, find all of our images, and then swap the source when they're in the viewport, right? The difference here is the lazy hits, it loads right when the image intersects with the viewport. But what if we want our image to intersect or load below the viewport, or we want to do different things after it's loaded? Well, we need an abstraction. And so this is imperative JavaScript for doing that. And that's not very much code. It's pretty awesome. Then we've got a declarative implementation in React where we can use this hook here called use lazy image. And this is just a teeny example that actually Claude wrote, that it shows that we can wrap all that declarative or that imperative stuff in a declarative abstraction. And then let's go look at this use lazy image. So we're in React, but we're still writing imperative code, right? We've got a use effect, and we're using this intersection observer. And we're using a for each, and we're doing other things, right, that maybe is not like pure functional or declarative or whatever. But we can put that in a certain context, and context is a loaded word here in React Town, but we can put that over here and manage it rather than having that with our UI components. And so we go back to the question, should it be declarative or imperative? Like, what's the best abstraction for an image component? And I would say it depends. And I would like to end by saying, may we all start in the pit of success and stay there. And I believe that learning declarative patterns and applying those in our work and our teams is a great way to do that. Thank you.